Welcome to today's webinar, AWS Database Migration Service and Amazon Aurora, getting technical with AWS database migrations. We'll get started just in a minute, but we'll let people funnel in for the next 30, 60 seconds. All right. Welcome to today's webinar, AWS Database Migration Service and Amazon Aurora, getting technical with AWS database migrations. I am Jay Martin, your host for the next hour. Certainly, if you have any questions throughout today's presentation, please add them to the Q&A section on the right side of your screen, and our team of experts will do their best to answer each before the end of the webinar. We are extremely blessed with the presence of great minds today, including Jonathan Trelles and Siddharth Mehta from Amazon Web Services, and Craig Nelson, one of the fine solutions architects at ClearScale. Before we begin, I would love to have each of them give a nice overview of not only their roles, but their companies. So Craig, if you would do us a kindness and please give us an overview of ClearScale and your role at the company.
Solutions architect or ClearScale. ClearScale is a premier consulting partner with AWS, which puts us in the top 3% of all partners in the AWS ecosystem. Our services range from architecture design, cloud migration, application design, all the way to support and managed services. We hold 10 AWS competencies, which we're rather proud of, naturally. Now, the AWS competency program is designed to identify and validate partners that have demonstrated AWS technical expertise and proven success in a given area, which is really just a long-winded way of saying that we've spent a lot of time developing expertise in those areas listed there in that table on the right. These cover areas such as data and analytics, migrations, DevOps, more vertical specific topics like healthcare, education, and nonprofits. As far as the team goes, the vast majority of our staff is highly technical in nature. We've actually completed over 1,000 projects with AWS. We like to say that we were born in the cloud. Our focus is and always has been 100% AWS. We don't spend any time on the other cloud providers, which ensures that we're able to move in lockstep with AWS at all times as their services evolve. And then lastly, we got a little nifty badge there you can see to the bottom showing that we're part of the AWS 100 Certified Partner Network, which means that we have 100 team members who are AWS certified, which really just means that we have the expertise and experience to make your AWS cloud initiatives successful, no matter how complex your needs are.
Fabulous. And now if Jonathan and Sid would tell us about this AWS I keep hearing about.
Yeah, sure. Good morning. Good afternoon, everybody. Jonathan Trelles here. I'm a migrations solutions architect with AWS. I've been with AWS for about 1.5 years. We concentrate on the migration competency, working with partners and customers to ensure that we go over their architectures, following best practice, methodology, and the well-architected framework. Sid, go ahead.
Yeah, this is Sid Mehta. I'm based in Seattle, also work with AWS as a partner solutions architect focused on migrations. One of my key responsibilities is making sure I work with our North America SI partners who are focused heavily on migrations, either are all migration competency partners or are planning to get there. And we help make sure the practice that they're following is in line with AWS best practices, and the outcomes that we can achieve will result in our customers meeting their goals, whether it be business agility, whether it be cost reduction, whether it be able to augment their existing capabilities with some native capabilities on top of AWS and make more out of their data and be able to move faster.
Excellent. Well, perfect. We have a 3-pronged approach to the webinar today, where we're going to start with Craig introducing everyone to the many uses of Amazon Aurora. And we're going to pass it over to Sid for a deep dive into AWS database migration. And then finally, a special treat. Jonathan's going to provide us a live demo showcasing how easy this can be for you and your business. So Craig, if you would be so kind to start us off and provide some wonderful insight into Amazon Aurora.
Sure thing. All right, what is Amazon Aurora? I guess that's why we're all here, but Amazon Aurora, is a MySQL Postgres compatible relational database built for the cloud. It gives you the security, availability, reliability, all the abilities, I guess, of a commercial database for a fraction of the cost. It's a fully managed relational database, which automates much of the time-consuming administration tasks, puts the burden of infrastructure management largely on the shoulders of AWS. You get to focus on your business, while AWS worries about the administrative details like patching and backups. And we'll get into some of the cool features here in a minute, but suffice to say that it's designed for performance, scalability, durability, and availability to ensure that the database, and more importantly, your data, is there when you need it. So let's talk about some features. So Amazon Aurora is backed by a clever distributed storage layer that allows for a number of cool features which aren't necessarily available with the other RDS options, such as RDS Postgres or MySQL. It would definitely require a sizable effort and cost to implement on EC2 or in your on-prem data center some of these features, namely crash recovery, fault tolerance, and self-healing storage. Aurora replicates your data with 2 copies into 3 availability zones, so you get 6 copies at no extra charge of your data in total. It can survive an entire availability zone outage, which would probably be a significant event. You'd probably hear about it on the news, but you'd have no interruptions, no performance degradation or data loss. If you have read replicas, Aurora will, which we'll talk about in a minute, but Aurora will upgrade that reader instance to become the primary and automatically reroute the traffic there. To do that same thing on more traditional RDS or EC2 installs would require a considerable amount of manual effort, which equates to minutes or hours your database is down, which you probably can't afford. Aurora can perform these actions on the order of seconds. If you happen to have cluster cache management enabled, you can even eliminate the cold start problem by ensuring that your failovers cache is even kept in sync with the primary. So that's pretty cool. Fast database cloning is another nice feature that you're not going to find elsewhere. You can stand up a new cluster, clone from an existing cluster without actually even copying the data. A fully functional database without copying the data. It uses something called copy on write, which really stores only the changed data, as opposed to making a complete copy of the other database. You can have a production database with a clone, and production database still operates perfectly fine. No one would even know the difference. But the clone, you can do whatever you want to the clone, and it doesn't impact the source database. And you can do all sorts of crazy stuff like experiment with schema changes or parameter group changes. If you've got some sort of tuning thing you'd like to do, you could perform workload intensive operations like an analytical query or something against that clone, and the original, the production database would never feel the hit. You could even copy it down into a lower environment for something like like load testing, so you don't have to wait for your administrators to do the full copy of however many terabytes of data you've got down into your load test environment. You can clone it and have it there in mere moments. So that's neat. Another cool feature is a database backtrack, which is similar but not identical to Oracle's flashback feature, if you're familiar with that. It lets you essentially roll back the database to a consistent state in the past. Like imagine you drop the table accidentally, of course. Backtrack lets you rewind the database to a point in time prior to when it was dropped. So it's similar in function to a database restore, but it happens much more quickly and with minimal downtime, since it doesn't require spinning up a whole new cluster. It just sort of rolls back the database to that point that you've requested. How far back you can go is configurable, but it's up to 72 hours. You can also backtrack on a database clone independently of the master database. So the sky's the limit on the fun you can have if you want to combine those two Aurora features. I can see having fun playing with those two things. Next up, we got snapshots, continuous backups, point-in-time restore. A little bit different than database backtrack, but Aurora backups themselves are continuous and incremental. So you can restore to any point within the backup retention period, which is configurable up to 35 days. Beyond that, you need to take a snapshot. You'd store it in S3, but the point is you can restore to any moment in time up to 35 days ago, which that's probably a pretty neat feature. Hopefully you won't ever need it, but it's there in case you do. No one ever wants to have to restore, but The reality is it happens. One cool thing you might do with that is you could test the validity of your backups. Anybody who's ever had to restore a database in an emergency situation and found out that your backup was no good and you had to go to the tapes and you found out the tapes were no good, you've probably lived that reality. This way, it's very easy to spin up a test cluster and restore to it. You can practice your DR scenarios without needing to buy additional set of hardware or copy data all around your infrastructure. You can do it sort of right out of the box with just a couple clicks with some of these Aurora backup features. Speaking of storage, the scaling is independent of the compute. So when you spin up an Aurora cluster, you have to provision the compute power you expect to need. But you do not need to provision the storage needs at any point in the process. Aurora manages it for you. So the storage volumes automatically grow as the amount of data in your database increases. So say you suddenly get a surge in data. Well, gone are the days of your storage administrator scrambling to present new storage LUNs to ASM or whatever database provider you're using. Aurora allocates that storage as you need it, which has a nice side effect of you're not needing to pay for storage capacity you might one day need. You don't need to buy that $1 million storage array because of storage needs you're going to anticipate in 18 or 24 months. You just pay for the storage that you need today, and there's really no cap on how much you're going to be able to use. Well, I guess 128 terabytes is the cap for Postgres, but the point is you don't need to pay for that storage up front. You just pay for what you need, and you consume it as you need it. As far as scalability goes, Aurora does offer you some really nice read and write scalability. If your application is read heavy, Aurora allows you to create up to 15 read replicas across multiple availability zones to take that load off the primary database. You can add these whenever, and you can scale them independently of the master database. The replicas themselves aren't synchronous, but they do have a very low replication latency, ensuring that your readers are not going to lag behind your writer. They're going to be about as sync as you can imagine. And you can direct the read traffic to a separate load balance endpoint, which makes it easy for those applications to accommodate the reader functionality. The read replicas themselves, they facilitate some of those fast failover mechanisms Aurora provides that I mentioned earlier. One important point is that the traditional RDS also offers read replicas. So Aurora is not exactly covering new territory here, but on traditional RDS, if you can even call RDS traditional, the read replicas can't automatically be upgraded to the primary in the event of an outage. You've got to take some manual effort to get a new instance stood up, and that takes time. Aurora handles all that for you. And then the last point on scalability, if you really need to push the limits, Aurora supports a multi-master configuration where multiple nodes can handle database read and write traffic simultaneously. So that's a neat little thing. So AWS has a whole lot of purpose-built databases, a wide array tailored to the specific needs of your application stack, from relational, non-relational, quote, web scale document databases, graph databases for relationship modeling, time series, and so on. AWS is a database service to meet your needs. It's all purpose-built to ensure high performance, scalability, durability, and availability. Aurora is just one service in a large toolkit. So it's definitely worth your time to explore what else is out there, because as your application continues to grow and modernize, Amazon's modernizing with you, and they've got the tools ready to help you succeed. Let's talk about Aurora and MySQL and the enterprise database at open source pricing. As I mentioned at the outset, Aurora is Postgres and MySQL compatible, which really means that your code, applications, drivers, tools, everything used today can be used with Aurora with little or no change. I did not mention that Aurora can deliver 5x the throughput performance of MySQL and 3x the performance of Postgres, although it does do those things. If you're using MySQL or Postgres today, those metrics alone should have you seriously considering Aurora in your near future. Now, Aurora itself is a managed service, which means that you get to focus your time and energy on developing your application and less time administering your database infrastructure. Again, it's compatible with MySQL and Postgres, so you get the cost benefits of running open source software while remaining behind the protective barrier of AWS. Both MySQL and Postgres are widely adopted commercially, and with Aurora, you have the added throughput and availability that your enterprise is going to require. And nicely, you only pay for what you use. Standard cloud model applies. If you need more storage, you don't have to buy that $1 million array. Aurora scales that storage as you need it. If you need more compute, you can scale up your cluster with just a few clicks. rather than going through that procurement cycle only to buy hardware that's soon outdated or sized for your peak demand, which maybe you need for 1 week out of the year. You scale up or down as you need, and you pay only for what you use. What a wonderful thing. So we go by the numbers. Here's a couple quick hit facts. Recently, they increased the storage limit. I mentioned earlier, now you can store 128 terabytes within Aurora. You contrast that with the cost of a storage array in your data center, basically about $12,000 a month versus $1 million storage array for capacity you might not ever need or might not need for years to come. It really makes a lot of sense. As far as scaling up goes, minimum 10 gigabyte storage, but the storage scales with what you use, no downtime or maintenance required to scale up that storage. And that 10 gigabyte minimum has to do with how the storage is structured under the covers, which facilitates things like those read replicas and high availability. From a database recovery standpoint, Aurora replicates your data, as we mentioned, 2 copies in 3 availability zones. So you get 6 copies in total, and you're not charged for those 6, just charged for the 1. Amazon's your buddy there. And it can survive an entire availability zone outage without any interruption, performance degradation, data loss, as we mentioned. And then one thing we didn't really talk about is those snapshots, and you can share them. You can share them up to 20 AWS accounts, although if you needed to go bigger than that, you can request that limit be updated. But a couple use cases for that might be separation of environments. If you want to share your database snapshots with dev, test, or prod in different accounts, or maybe you've got you're partnering with someone who you need to share data with. Taking those snapshots and sharing them across accounts is a really handy feature to give other people access to the data within your database. So that's everything I've got there. I guess it looks like it's time for a poll question.
Yes, absolutely. Thank you, Craig, for that great overview. Are you planning or actively performing database migrations right now? So you'll see the poll question pop up and a few different options there: researching only, planning, currently performing, or possibly you have already completed and just want to make sure that you've done it correctly and see what else is out there. So we'll give just a second for some of these answers to come in, and then we will move on to our next section where Sid is going to walk us through the AWS Database Migration Service. Excellent. Well, it looks like we do have a healthy group of people that are currently performing AWS database migrations. And so great that you have decided to join us today. And certainly if you have questions both during the presentation or after the presentation, we are more than welcome to answer anything that you have. So please do use that Q&A section if there's anything you would like answered today. Otherwise, Sid, I'm going to pass it on to you and let you give us a great overview of the AWS DMS.
All right, thanks, Jay. This is Sid Mehta again. So let's talk a little bit about the AWS Database Migration Service and why it was created. So as I can see here, a lot of you are already performing migrations. Some of you are in the researching phase and somebody in the planning phase, right? So AWS Database Migration Service was created with the intention of helping you move off of your common commercial databases, whether it be Oracle, SQL Server, Teradata, over to AWS. And we saw the whole list of purpose-built AWS databases that you have at your disposal. And let's talk a little bit about Aurora today, right? So you can see there's a significant potential in terms of higher performance, lower cost by migrating your applications to Aurora. However, there will be some steps involved that you'll have to take in order to be successful with your migration. So depending on your scenario, you may be wanting to migrate between on-premise and AWS, right? You may want to just migrate between databases. So let's say you are trying to either modernize to Aurora, or you're just trying to take your existing say Oracle database and have it hosted in RDS on AWS, basically, and let AWS take care of some of the management, the patching, and the heavy lifting that has to happen behind the scenes. All you have to do is be responsible for your data. This is where the database migration service can help as well. You may be looking to do a heterogeneous, database migration. meaning going over from a SQL Server engine over to Aurora, and you're looking to for some tools that can help you with an automated schema conversion. So we're going to talk about that as well. And if you're just trying to do data replication for a zero downtime migration, so you've done your initial migration, but you need a tool that can help you with change data capture, track any transactions that are coming onto your primary data source, and then you want to replicate those over to the cloud for a variety of reasons, right? It could be for a zero downtime migration. It could be for augmenting your existing functionality with, say, SageMaker, some of our AI ML tools, and making more sense of your data, or using our tools like QuickSight and Redshift or Athena, to be able to query your data and start your data lake, so to speak. So you can use DMS for all of these kind of purposes. So typical database migration lifecycle will involve starting out with some analysis, right? You may have one database, or you may have a portfolio of databases that you're looking to migrate, depending on what your goals are and how quickly you want to either migrate the application to the cloud or move an entire data center to the cloud. So there are tools you will need in the analysis phase. Then we start looking at the schema objects. What are my tables? What are my indexes, stored procedures, functions, data types? And how am I going to migrate those over to the target database, whether it's a homogeneous migration, Oracle to Oracle, or whether it's Oracle to Aurora, right? And then you start looking at the rows of data that actually have to migrate from the tables, right? How are we going to migrate those over to the cloud? And next thing is, what kind of validation tools am I going to use to make sure that the data is migrated the way I expect it to be migrated? You then have to start looking at refactoring your application, especially if you're switching the database engine and you're migrating from Oracle to Aurora, SQL Server to Aurora. And then you'll be in this loop doing some kind of unit testing, performance testing, UAT, before you can actually do a cutover, right? So let's talk a little bit about how these tools that AWS has to offer fit into this life cycle. So this brings us to the two tools that we're going to talk about and a lot today, which is DMS and SCT, right? So DMS stands for Database Migration Service. And as the name suggests, it will help you migrate or replicate your database on-prem to databases in AWS, or vice versa, right? So the really good thing about DMS is it is a service that helps you move your data between on-prem and cloud, or between cloud and on-prem. It works both ways, as long as you have either the source in AWS or the target in AWS. What it does do is it'll help you create the tables. It'll help you create some of the primary keys that you need, and start moving your data over. But what it doesn't do is, if there are additional objects, secondary objects, like you have foreign keys, and whether, say, you have constraints, or you have custom data types, and you have stored procedures or functions that you want to migrate over to your target database, whether it be Aurora, whether it be a different database engine than what you're using today. This is where you can leverage the AWS schema conversion tool. And it helps you automate the job of migrating those secondary objects over from your source to your target, basically. So if you're trying to migrate to Amazon Aurora or Redshift, SCT is going to be your friend. It will help you with assessment, and it also helps you with the actual automated conversion, and also gives you a report of things that may or may not fit, and then you can do them manually as well. So we'll talk a little bit about that as well. So when to use DMS and SCT? As you can see, there's three scenarios here that fit really well for these tools. You're trying to modernize your database, and say you're trying to upgrade the database engine, whether it be for cost reasons, whether it be for better resiliency than what you have today, whether it be better performance that you want, or you're trying to standardize, across the enterprise on what kind of engines you want to use. So you can use DMS and SCT, a combination of those tools, to modernize your database engine and migrate to, say, if you're using DB2 and you wanted to come over to Aurora RDS, PostgreSQL, you can use it for that. You can use it for just migration. So you don't want to change your database engine, but you want to retain the engine. All you want to do is migrate from on-premise data center to the cloud. You can use it for that. And then you can use it for replication, meaning just keep track of your changes, ongoing basis, do change data capture, and keep them updated. So when would you use schema conversion tool? Let's talk a little bit about schema conversion tool, right? So when we already discussed that if you're trying to modernize your database, right, and you're trying to move over from, say, Sybase, Oracle, Teradata, SQL Server, and you want to either go look at Aurora, PostgreSQL, or Aurora MySQL compatible engines, the schema conversion tool is going to be your friend. It's going to actually start looking into your schema, into your functions, stored procedures, and help you provide with some kind of estimate and a starting point for the effort that it's going to take to make sure all of these objects get converted over to your target database. It will provide you with the tools that you need to do a side-by-side comparison of what code you have on the source side and what will the code look on the target side. And if there are things that it cannot do, it's going to give you a report for that as well, and even provide you with some high-level estimates in terms of time for how complex some of those objects might be that it cannot convert. Also, another area that we can use SCT is actually migrating your data to our data warehouse or to Redshift. So SCT does ship with what we call our data extractors, basically, which let you migrate your data over from your on-prem, say, Netezza or Teradata data warehouse, and send it over to S3, from which you can actually feed it back into or push the data back into Amazon Redshift at a very fast pace. Since Redshift is a node-based database. So it helps you actually modernize and migrate some of your database, your data warehouse databases over to the cloud as well. And it can also be the starting point for building your data lake in S3 as well. So let's talk a little bit about the conversion tool. What does it look like and how does it work, right? So like we saw in the migration flow, basically, where you start with an assessment and the next thing you do is your schema objects, right? So this tool here is going to be able to connect to your source database as well as your target database. Let's assume your target database is empty. There isn't anything there right now, but your source database, you can start exploring the list of tables and the objects that are available in your source database side. You can right-click on any of those objects and look at a report, especially when you see those little red dots here. There is some work to be done in terms of conversion by the schema conversion tool. And when you open it up, you can actually see your stored procedure on the left side, and you can see what it will look like. Say, if this was an Oracle stored procedure here, and how would it be converted to a PostgreSQL compatible stored procedure on the right side for your target database. So you can start to look at your code browser, start looking at things side by side, and it helps you prepare a report of items or objects, basically, that can be converted easily and the ones that cannot be. So when you right-click onto the left side of the schema and just say generate a report, it will produce a report where it says, what is the percentage of your objects, say by schema, by tables, column, constraints. The green is great, basically, because it tells you that the objects can be converted automatically. Or it starts to change colors here, where you start seeing some blue, where it says it can be converted with a few simple actions. There may be a few steps that you need to take. The red, or when you start getting into the yellows and the oranges, is where there might be additional steps or significant actions required, because there may be some features in the PostgreSQL side which are not necessarily directly compatible with what you're coming from. And this is where you start to make some decisions and start to look at how you're going to start migrating over. So when you get to this level of a report, you can start to estimate the time and the effort it's going to take, and you can start seeing what percentage of your objects are going to be converted easily versus what percentage of the objects were going to need some manual attention, and what kind of skills will you need to help get there, basically. Also, to assist with the migration, because heterogeneous migrations can be complex, and depending on where you're coming from and where you're going to, AWS listened to what their customers really wanted, based on the experience that we've built we've got from the field, and along with partners like ClearScale, that have provided a lot of inputs. What you will find are these migration playbooks. And we call them old world to Aurora migration playbooks, but there's a playbook for, say, migrating from Oracle to Aurora PostgreSQL, Oracle to Aurora MySQL, or SQL Server to Aurora MySQL. So you'll find all of these playbooks. Some of these guides are about 350 pages long, and they go provide you all the steps that you need to take step by step to kind of launch the SCT tool, download it. It's basically a Java-based utility that you can download onto an EC2 machine, point it to your source database in your on-prem environment, and run this analysis without actually having the data leave your on-prem environment at all, basically. And then it also talks a little bit about all the features and does a feature comparison between your source database as well as the PostgreSQL feature that you either have or may not have, and then provides you with a few options or best practices for how to manage the conversions for the features that may not be supported, basically. So this is the link here to the resource, and I'm sure if you're already in the process of migrating, you've probably downloaded these books. If not, these are the best practices that are going to be very, very helpful when it comes to performance tuning, just migrating, and actually reducing some of the time it takes to go from whatever source you're coming to over to Aurora. And then when do you really want to use DMS, right? So let's say you've got the schema converted and you've created a target, which has tables created out there with some keys, but doesn't have any data in it, right? So DMS is really going to be your tool to start migrating the data over, basically, for you. And you can actually migrate from a variety of sources into AWS, basically. So data could be coming in from Oracle, DB2, SQL Server, or MySQL on-prem over to Aurora, DynamoDB, Redshift, S3 into AWS. Or you could have AWS be a source here, basically, with Aurora in here, and you could still be sending the data back to your on-prem, basically. So it could go either ways, and you can have DMS support your business critical applications. Let's say you have your critical applications already running on-prem, but you need a copy of that database in the cloud because you want a leg in the cloud and you're starting to explore some ways of making more sense of that data. This is where DMS is really going to help you start to build that copy of your database in the cloud. If you want to start building a data lake and say start exporting a database over to S3 and then start connecting to that database, you start bringing it into Redshift to make some sense of it. This is where DMS is really going to help you as well. So there is DMS also is not just a database migration tool, but DMS has the ability to actually go heterogeneous, as we see here, and it can also help you migrate between different schemas. So you may or may not always need SCT, and it just depends on how complex of a schema are we looking at. If you're looking at a really simple schema where you don't have a lot of secondary objects or a lot of stored procedures and you just have a small database, DMS might just do everything that you need as long as you just have like basic primary keys, basically. But for the most part, I think if you're looking at production grade workload, I think you're going to have to use SCT first to do the schema conversion, followed by DMS to do really the data migration. And DMS has some built-in validation tools, which are going to help you reduce the time it takes to test and validate the data migration itself. So you can actually start looking at potential issues or unsupported data types, which can happen a lot between different database engines. And it can actually help you validate your data row by row and show you a log as well as some results of where you have mismatches or the total number of rows that either matched or didn't match, between the source and the target database. So that's going to be a starting point to start looking for proper errors, mismatches, and things that you may need to either update back going to the schema conversion tool or do some kind of transformation for that data before you can bring it over successfully. You also have a really good option here where DMS can work with Snowball Edge. And Snowball Edge, for those of you who don't know, is basically a portable storage device, which can have up to, say, 80 terabytes of storage. It can be ordered through the AWS console, and it ships to your data center, just like you would order something off of Amazon Prime and have it shipped in 2 days, to your data center. So when we're dealing with really large databases, makes sense for databases going over 5 terabytes. And let's say you don't have a dedicated pipe to AWS where you can start moving either the terabytes of data or in a reasonable time frame. We're starting to look at multiple days, if not weeks, of time that it takes to move the data over. This is where Snowball is going to be really helpful. Let you make a copy of your databases on-prem, over to the Snowball device. And then once that's done, you pack up, whether you bring in 1 database or 10 into that Snowball device. And the data is always encrypted, using your KMS keys. You ship the device back over to AWS. It will be connected back for you in the region of your choosing. And in this situation, you have a push, of your data basically from your on-prem to AWS. Basically, once it is there, you have the option of restoring that backup over to, let's say, RDS, or you can actually then start to run DMS, on that data in the cloud and have it converted over to, say, Aurora for that matter, basically. Or you could even just have it exported to S3 and be the beginning of a data lake. So as opposed to relying on a pipe and spending days and days to transfer large amounts of data over, Snowball gives you the option of packing, all the data into basically a disk that is encrypted and provides a secure and reliable way of actually migrating your data over to AWS. So when to use DMS, right? So it can support several scenarios for replication, basically. Say you want to create a cross-region replica for your databases and you want to go across different regions, DMS is going to help you do the change data capture and build the replicas. Let's say you want to run analytics in the cloud. So we talked about, where you have your on-prem data center, production data centers there, but you want to just start exploring abilities in the cloud and start to build your data lake. So that's where it's really going to help you move your data to S3 from where you can ingest it, into additional tools, AI, ML tools, that will start to make more sense of your data and help you grow without necessarily refactoring any of your applications on-prem. And also a really good scenario would be for your dev test and production environment sync, right? So you have, say, for example, some environments where you're doing testing prior to going to prod, but the only way you can really do a performance test is to have data sets that are as large as production. So you can see the performance times and the query plans for your data. You can use DMS to keep these test environments in sync with your production data sets and just use it as a change data capture tool to actually have those environments be in the cloud. Your test environments could be in the cloud, and then you could be replicating data over from production to your test data. So it supports a variety of use cases and different scenarios where it makes sense. And talking a little bit about how it works. So database migration process, right? First step, as we discussed, you look at your source database, look at the schema, the objects, and you can use the schema conversion tool to perform an assessment to kind of get a report of what objects can be converted automatically and brought over to your destination database. And then if there's manual conversion involved, it will give you a report of those objects too, the fallout objects that may not be able to convert automatically. So if you have to look at some of those stored procedures yourself, you can do that. And you then have the option to either use native tools. If you're going, say, homogeneous, you can just going from Oracle to Oracle. You could use Data Pump, right? Or let's say you're going from SQL Server to SQL Server. You could use you could do a backup restore if all that you wanted. I mean, if you don't have to use schema conversion tool, that's always an option. Native tools are always an option when it comes to homogeneous, migration, because you can do simple backup restore using our SQL Server console and get your back file moved over to S3 and then have it restored over in the RDS instance in AWS. Then also where it's going to help you move your data, say, is if you've got a database on-prem and you're just trying to have the data migrated, DMS is going to be a great tool for helping you migrate that data over as well, basically. And for data warehouses, we have the data extractors that are built specifically into SCT to help you speed up your data extraction from your Teradata, Netezza kind of data sources, and then have it migrated over to AWS for ingestion into Redshift. So how does it work? Let's talk a little bit about how can you achieve near zero downtime when you're using tools like DMS and SCT for migrating to, say, Aurora, right? So you've got your, I'm gonna try and see if I can do a little bit of drawing here, but you've got your on-prem data center with a database here, an application database that your application users are connected to via our application servers. So let's assume this is step one, and this is all that they're connected to is on-prem. Now you deploy a DMS instance, which is a replication instance that runs on an EC2 in AWS, basically. You can pick different instance sizes depending on your requirements. So let's say you deploy this instance over to AWS, and you have a VPN connection between your data center and AWS. So your instance is now able to talk to the source database on-prem, as well as has a target connection to the AWS database that you provisioned, which is your target, could be an Aurora PostgreSQL database. And say you're migrating over from Oracle to Aurora PostgreSQL here. You provision a database here and define this as your target, and then you're connected back to your source, right? So you've got this as your first step here going in, right? Then you start to select the table, schema, or the databases that you want to start migrating over, right? So you do your schema, you use a schema conversion tool to make sure that your objects are moving over from on-prem to AWS. And once they are, you also start to migrate your data over from on-prem to AWS. So DMS is going to help you migrate all the rows of data from your different tables over from on-prem to AWS. Once that's done, DMS will also help you do some change data capture and keep these in sync. And once that's done, it's in sync. There's ways to verify that using our logs. All you can do is you can disconnect this particular connection here, do a CNAME swap, and have this application connect over to the database in AWS. So this would reduce the impact that your users are going to see in terms of downtime, and it helps you, run tests on the target database without impacting the production, before you can do the cutover as well, basically. If at all, there may be a small glitch, while you're doing the DNS query for the CNAME change. But other than that, you can avoid any large kind of downtimes and still have a database engine swap performed. And when you're starting to look at high availability or multi-AZ, so we do have the option when you're provisioning your DMS instance through the AWS console is to pick the multi-AZ option and define the two AZs that you want your DMS service to be deployed in, basically. So all this allows is make sure that when you're actually doing your migration or your replication of your data from on-prem to AWS, even if there is a fault or an outage in one of the AZs, or there's a problem with your DMS here, you can automatically switch over to the other DMS and still have the replication continue. So you do have that option even at the DMS level for mission critical workloads. What DMS does do is it takes data table by table. So what you have the option of either taking all the tables, some of the tables, creating some of the data inside of some of the tables, and you can actually have regular expressions or different filters that you can use. So you can decide, depending on your particular requirement, if your target, say, is just a test environment and you need a subset of the data from production, then you can actually have the filters set so that you only have a time series slice or a subset of the data that you need for production in the cloud, basically. You don't have to replicate everything over. So you have the option of taking all tables, some rows, all rows, and that's a really powerful feature here that DMS brings to the table as well, supporting different scenarios. You can also have change data capture as we discussed. So you have your initial migration done, and you've migrated, say, all the data over from on-prem to the cloud. And now you have updates that are flowing into your on-prem data center. And we have a transaction log on the left side, which keeps track of any changes that are happening to the data here. DMS basically can read the transaction log and make sure it replicates all of those changes continuously ongoing over to the AWS side as well. What I must say is this is not a two-phase commit. So you can have these changes happen here, but the replication is asynchronous, and it's not going to necessarily slow down your database at all. And in most cases, it is caught up in a few seconds, if not a few minutes. Basically, you should, depending on the latency that you have, between your on-prem data center and AWS. And so I want to summarize a little bit by talking about some of the advantages of these tools that you have at your disposal for database migration. Lets you migrate your database over from, say, the same database engine that you have on-prem, in this case, Oracle, to RDS Oracle, or you can actually switch your engine out to get away from, say, some kind of punitive licensing that you may have, or just trying to standardize on one particular technology and migrate your databases over from, say, SQL Server to MySQL. Or you can actually start to build your data lake and extract data from Oracle and have it in S3, which is the beginning of your data lake kind of solution. So it will support multiple scenarios, whether you're trying to do homogeneous or heterogeneous migration. And with that, I want to hand it back over to Jonathan for the demo.
Hey, thank you, Sid. I don't think we're going to have enough time for the demo. I know that we have a few slides coming up on ClearScale's use cases as well. But Jay, if it's okay with you, I just want to explain it hypothetically at the high level, and then we'll pass it along back to Craig to make sure that we can go over the other content as well. But in any case, like Craig and Sid mentioned, DMS has three main components. We're looking at the replication instance, we're looking at the source and target endpoints, and then the replication task is what's actually moving that data from source to target. And that's why we have to configure carefully the source and destination endpoints when we do our database. So in this demo, we actually had a hypothetical environment, WordPress and off-biz databases, supporting a WordPress application and a BI solution running on Postgres as well. The platform was actually MySQL and Postgres, which was native to Aurora. As it was mentioned in the presentation earlier. Compatible drivers for Postgres and MySQL are available to Aurora, so we can easily deploy those when we set up the infrastructure because it gives us that compatibility. And the provisioning could be something that we specify, like the actual instance type, or it could be something that's serverless, where the auto scaling is automated based on the actual usage, and that's good for like infrequent or unpredictable workloads. In any case, in this hypothetical demo, the migration was going to be separated into three main steps. The first step was to configure the target database. In this case, it was going to be Aurora, setting up the database, the actual infrastructure, and then the account for us to be able to connect to that database. And then the other steps were going to be configuring DMS, our data migration services, setting up the subnet groups, the replication instance, and the source and target endpoints. And then the last step was going to be doing that migration from source and target databases with a database migration task. Depending on the size of the database and the actual data being migrated, it could take a few minutes to a few hours. And the size of the replication instance depends on how much data we're moving and the velocity that we need to move that data as well. And then lastly, after our tables get updated, our schema gets migrated. The next step was going to update DNS for our application to connect successfully to our newly Aurora migrated database. So again, one main key takeaway from this would be the three components to DMS: the replication instance, which does the work behind the scenes, migrating from source to target. The source and target endpoints, which specify where the data is coming from and where it's going to. And then the replication task, which could be scheduled or automated as well, that kind of specifies what is being migrated, what source and what target I'm going to be using for that migration, and when I'm going to be delivering that migration. Anyway, so that was going to be the demo. Sorry, we didn't have time to do it today. We had a lot of content to cover. Having that said, I'm going to pass it over to Jay.
Well, I appreciate that, John. And as a teaser, we can certainly apply a demo to the upcoming webinar on migrating mission critical databases. So everybody should just register again and show up in December for that full scale demo. So I know that the content was going to be great. And again, I thought everything that Sid and you covered was still fantastic. So great work by both of you. But now I'm going to hand it over to Craig, who's going to go over a couple of real world examples and how ClearScale helped, especially during a MySQL and PostgreSQL database migration.
Right on. So obviously Aurora is gaining momentum. It's I guess the fastest growing service in AWS history. It's used by a significant portion of the top 100 customers. So if that doesn't give you any encouragement to get over, then probably nothing will. But let's talk about this, extend this beyond the purely theoretical, and let's talk about a couple times we've actually done this. And I say a couple, we actually do this pretty much every day. But Sierra Club, they had a public-facing online advocacy platform, but they lacked flexibility due to some design choices and management structure. There was a third-party MSP who was responsible for all their access, which gave them a lack of visibility and access, and control of the environment made troubleshooting hard. They also had some performance issues, the environment, and challenges in scaling the MySQL database that they didn't really own. So the solution was for ClearScale to build out a new architecture in Sierra Club's own AWS account. We migrated the databases to Aurora MySQL using the aforementioned database migration service. Leveraged some other AWS services such as CloudWatch to help their IT leaders monitor resource usage and really gain visibility into the performance and the overall health of the system. So the results is that they gained control over their platform. By migrating to Aurora, they gained the ability to scale the database more or less at will, not to mention the performance boost by moving to Aurora. And it's now much more agile thanks to the new AWS infrastructure. Another one we did was a client called Entropix. They're a computer vision software company that uses AWS services to construct or reconstruct video and other images to really improve the accuracy of computer vision applications. It's a pretty cool thing. The challenge was that Entropix wanted to deploy a new on-demand SaaS architecture for their processing engine. Now, the existing system was Postgres on EC2, which meant a lot of VM administration, effort for backups, non-trivial scaling. It really just required manual effort and manpower to support. They had limited visibility to cloud-native type monitoring, and the team itself had limited experience in AWS. So the solution was ClearScale was asked to modernize and refactor layers of the application into Elastic auto-scaling groups using Amazon's Elastic Container Service. We decoupled the application using Amazon Simple Queue Service, and we dynamically auto-scaled the application by monitoring queue depth. So simply put, really, like more messages in the queue means that the app would scale up automatically, and as the queue emptied out, then the app would scale down automatically. We also transitioned storage from Elastic Block Storage to S3, which is much cheaper and scales easily with demand. And they migrated the EC2-based Postgres to Aurora Postgres. They took advantage of multi-AZ configuration to facilitate better availability and DR capabilities. And management tasks such as backups and patching became largely AWS responsibilities, and who doesn't want that, right? The result was that the new architecture built to scale along with demand, and Entropix capabilities are open to a much larger base of customers. And using AWS managed services allowed the clients to spend less money and time on infrastructure and more on their core business. So that sounds like wins all the way around. Now, as far as ClearScale's database migration offerings, there's three phases in any database migration, with a fourth phase, taking things into the great wide open of database application modernization. And really, these are the same steps that we just went through to the course of this presentation. Really, it's the database strategy and assessment. Figure out what you've got, what the schema conversion tool looks like, building a little POC, making sure that we're happy with those results. Moving to the managed database. Typically, that piece takes 8 or more weeks, really depending on the size. we're going to optimize that strategy, how we're going to figure out how we're going to get that data from point A to point B. Do we need a Snowball or a Snowmobile, or, can we just, use traditional methods to get that data there and actually begin doing that migration, offline or online? Either way, the legacy database remains, operational and the source of truth, as we saw earlier. The third step is the actual legacy database migration. That can take at least 12 weeks, depending on the size and complexity of your database and application. We actually migrate that database engine. It means, refactoring and stabilizing application code to make use of the new database, and ideally eliminate or at least lower the costly database licensing needs. Get off that name brand database that probably drove you to this decision in the first place. And that last step is really the big one, and is really sort of indefinite in terms of how long it can take, but depending on how deep into the woods you want to go. But looking at architecture reviews and design documentation, understanding what problem you're trying to solve with a modernization effort, migration plans, how you're going to get there, and incorporating the necessary application refactoring to leverage a new database backend, which could drastically alter how your app interacts with the database. If you're going from relational to SQL or time series or graph, there's a whole wide world of cool things out there that might really enhance your application's capabilities, but it's going to require a little bit of TLC and on the application side itself. And then of course we actually execute that at the end of that period. So it probably makes it look really simple, 4 little colored squares on a slide, but the thing to remember is that ClearScale is here to work with you every step of the way, and you'll be leveraging our expertise in this arena to make that migration successful.
Excellent, Craig. Thank you for the quick overview there. As we begin to wrap up, we did have a couple of questions that poured in, so I would love to pass this back to each of our individual experts. And we'll start with, what's the difference between running a database on EC2 versus RDS Aurora? And how do I estimate the cost differences between each of these approaches? Sid or Don?
Sure.
Perfect.
Yep, Jay. Hey, this is Sid. Yeah. So one of the biggest differences, I think, between running on EC2 and RDS is if you have a database that you want full control over, including the version, the patching, and say you want to continue operating your database just the exact way that you operate it today in your on-prem data center, EC2 is an option which you can leverage to maintain that level of control. But say, and it's also probably an option that you can use when you're dealing with databases that don't have a destination that, or let's say we don't have a path to migrate over, say to Aurora or to RDS on in AWS. But if you're running it in RDS, then Amazon basically takes over, AWS takes over a lot of the undifferentiated heavy lifting for you, and all you do is secure your data and basically takes over some of AWS takes over a lot of the management for you and gives you a lot of the resiliency and scalability features out of the box, with RDS in there.
Got it. And then John, one for you. What if I have to manage multiple database replication tasks? Is there a way to automate the process?
Great, that's a good question. Yeah, so DMS in the console, we have the ability to create the actual replication task to move from source to target, and that's done through the console, the UI, and there's that checkbox that says start when the replication task is created. We can uncheck that option and make sure that it's ready, and we can kick it off whenever we need to, right? Which is great. But the question is, what happens when we have maybe hundreds of replication tasks? If that's the case, then the AWS CLI or the SDK is going to give us the ability to manage and orchestrate the replication tasks with DMS at scale. So that's something that customers can leverage as well in case we have multiple database migrations. And we do have plenty of documentation on that as well, which is something that we can provide.
Perfect. Well, it looks like we are up against the clock at this point, but should you have any questions, please feel free to schedule a consultation with one of our solutions architects by simply reaching out to sales@clearscale.com, or I'm sure each of the fine gentlemen on this webinar would love to assist you as well. A couple of great follow-ups to today. Like we mentioned, the Migrating and Modernizing Mission Critical Databases webinar will be December 10th. Those invitations are going to be coming out very soon. This is definitely one to be on the lookout for. The phenomenal team of Sid, John, and Craig will be back again to help dispel any migration fears, help you understand the undeniable benefits of moving your mission-critical databases to AWS. And I'm sure we will try to fit in a demo with Jonathan in the next one. And then we've also got a Get Comfortable with Container Technology webinar, which is planned for December 3rd. Those will be coming out soon. And this is going to walk through what to expect when you deploy your first container and the variety of services, including ECS, EKS, and Fargate. And then finally, again, a very generous thank you to Sid, Jonathan, and Craig for taking the time to help with today's event. And I know I'm excited to learn from each of you guys once more in December. So thank you all for all the attendees. We hope to see you at many more of these webinars to come, and have a great rest of your week as we look forward to discussing database migrations with you again very soon. Thanks, everybody.